So, okay, so this talk, I call it the other dilemma not in Netflix. It's about the social dilemma of modeling polarization in social networks. So the outline of this talk is I'm gonna give you some motivation to work in polarization in social networks. I'm gonna introduce a model of polarization. I'm gonna show some simulations in this model. And then I'm gonna show some theoretical results that are very insightful, I think, for polarization in social networks. So first, the motivation, why this problem is important. So social networks. So the dilemma the dilemma is that there is the good and the bad. The good is that the world is becoming more interconnected. You have more access and prompt exchange of information and opinions. And you have the exposure, you can see diverse perspectives, which is healthy, that's good. The bad, what's the bad? That you have millions of users targeted with selected information. And these, on top you have cognitive biases that get generated on a unprecedented scale. So cognitive bias is a systematic pattern of deviation from rationality. That basically you act in an irrational way. Humans are, I think, inherently irrational. I'm exaggerating a little bit here. Let's say that all humans are subject to bias, even scientists. So cognitive biases in the political arena, you know some of them. One is confirmation bias. We'll be talking about this one. You have coverage bias. This one is when you actually start to give an excessive coverage to some situation, and that creates the idea that it must be true if you are reporting in this way. So for example, if somebody gets accused by the Supreme Court, and you cover this process like the whole day, then this starts to play with your brain on the way what you think is true or not. Other biases, there is the survivorship bias, which consists on focusing on the successful and ignoring the failures. A typical example is, for example, this guy here who claims that you should never stop buying lottery tickets, no matter what anyone tells you. I failed again and again, but I never gave up. I took extra jobs and poured the money into tickets. And here I am, proof that if you put in the time, it pays off. Of course, ignores all the people who never won anything. So authority bias is another very important one. We'll be talking about this one. And it's like people are more likely to trust and be influenced by the ideas that come from authority figures. Availability cascade, the idea that accumulates more credibility as it spreads. A typical example when you say, let's say you say, I have heard from a bunch of people that he's going to raise taxes. So it must be true. It must be true because I have heard from a lot of people that something is going to happen. And groupthink is when you basically conform to a widely held worldview in order to fit in. So you want to minimize conflict, you want to be accepted. False consensus, when you overestimate the proportion of people who agree with you. And this one that is very, very common, the Dunning-Kruger effect, is that for some reason, the less that you know, the more confident that you are. So you have a lot of influencers, influential people that they don't really know much about, but they're very confident that they know about this. So they are experts in COVID, they are experts in economy, they are experts in everything. So these are the kind of cognitive biases that we'll be talking about. For this talk, I'm gonna focus on these ones: confirmation bias and authority bias. Confirmation bias is the tendency to search for, interpret, and recall information in a way that supports your own views. So basically, you are just reinforcing your own beliefs. Here's a typical joke from Dilbert. I don't know if you know Dilbert. But look at this boss here is talking to the engineer and says, if your numbers are correct, my strategic plan is irrational. Then he gets this sudden cognitive dissonance inside. He realizes that this contradicts his own conviction. And then he goes like, you sure are bad with numbers. So he's basically trying to correct in favor of his own beliefs. And this is also very common. The other one is authority bias. Authority bias is the tendency to be more influenced by the opinion of an authority figure, oftentimes, even if it's unrelated to his content. Typically, you see a picture of Einstein talking about, I don't know, love, stuff like that, and it must be true if Einstein said it. And then you have influential figures that are feeding fake news, and lots of people believe to be true, millions, in fact. And you have influential figures everywhere. In the Colombian scenario, you can have at least two people that you can think that are very influential people. Basically, sometimes their beliefs are shaped by these people. Their opinions are shaped by these people. And that's another kind of cognitive bias. And this cognitive bias, they generate echo chambers or filter bubbles. So an echo chamber is an environment where a person only encounters information he already agrees with. So typically you are in this place where people are of the same color. That means that they kind of similar to you, your beliefs are similar, and you get fed whatever you like. And typical echo chambers, Fox News, for example, on one side, and if you're in the other side, CNN is also an example of echo chambers. In Colombia, I don't know if you know La Hora de la Verdad, but you have to have certain ideology to feel comfortable if you are listening to this program, for example. So, and these echo chambers, they can generate a polarization, which is the us versus them. So look at this picture. It's hard to explain, but this is the House of Representatives in the United States back in 1979. The House, you'll see that you have polarization. You have people of certain ideology on one side and the other, but there was some kind of collaboration in these circle areas. And now in 2015, the same house, there is much less collaboration. So there is more polarization. Polarization is basically a split in clusters of groups of the society around a given subject. Typical example in Colombia is the peace process with FARC. So things that are important in polarization at the small groups do not really matter. If to have polarization, you have to have groups of considerable size. And polarization increases with intra-cluster similarity. So the more that the people are alike within a cluster, you get more polarization. And inter-cluster differences. That means if people from different clusters are very different, that increases polarization. Example of high polarization: Brexit, USA and Brazilian presidential elections, and the Colombian peace referendum. Polarization in Colombia, this is interesting. So do we have polarization in Colombia? I was reading about this and I found this article in Semana, who concluded that from this table, that it's not clear that there is polarization and Colombians are centrist. Look at this. This is basically, you are supposed to grade yourself from 1 to 10 about your ideology, your political ideology, one being from the left and 10 being from the right. So apparently from 2004 was 6.6, and now in 2016 we are in 5.8, and that's the average. So the article concludes this, but this is amazing that this is in actual article, because you take this example and you have high polarization in that group there. You have two big groups, very separate from each other. And the average is the same of this one that is low polarization, because people are like uniformly distributed around this area. So you cannot look at the average and conclude things about the average. Otherwise, some countries that we have, Denmark, we have beautiful weather because the average will be 15 degrees. Okay, so this is basically what we have seen. Basically, social networks facilitate, intentionally or not. I don't take this debate of whether it's intentional or not, but influencers shaping our users' opinion. That's authority bias. Echo chambers reinforcing users' opinions. That's confirmation bias. And this might cause splits in societies, so polarization. And polarization, we all know that have a great influence in democracy and human behavior. So it's a very important phenomenon. So what we're gonna show next is a mathematical model for the dynamics of polarization. So the polarization model. So our model has some static elements. And in that model, we have a set of n agents. And there is a belief states, which basically tells me how much a given agent believes in some given proposition P of interest. And there's the influence graph. The influence graph tells me how much an agent or user influences another one. So because we have this influence bias, so this is important. Here's an example. So let's take the peace process with FARC. Let's suppose that you have 6 agents, the users 0, 1, 2 to 5, and we have a proposition P of interest, which is the peace process is good for the country. And let's suppose that the initial state of affairs is the following. Agent 0 is expressed in this vector here. Agent 0 completely believes not P. So he's totally opposed to the proposition P. So he thinks that the peace process is bad for Colombia. Agents 1 and 2, they strongly oppose P. They do not quite reject it. So the peace process must be rewritten probably, but they are more or less like, it's not to be trashed. And then you have agents 3 and 4 and 5, which all actually strongly believe in the peace process. And let's suppose we have these influences. So we have, for example, agent 5 has a strong influence over agent 0. The maximum influence is 1, the minimum is 0. And then you have the, for example, 0 has an influence of 0.6 over 1 and 0.4 over 2. So this is basically the static model. So you have an influence graph and the belief that every agent should hold about a given proposition. So now we come to the issue of how do agents update their beliefs? So in social science, as we discussed before, have explained to us that there are there could be two kinds of belief updates. One is the authority bias, which we call irregular, and confirmation biased. So let's see how it happens. So for authority bias, basically you give more value to the opinions of the people that influence you the most. So here's the update function. So this means the belief of agent I given the belief of agent J at time t plus 1 is the belief that agent I has now at time t, plus the difference of belief between agent J and agent I multiplied by the influence that agent J has over I. The confirmation bias is similar, but you have to give more influence to the people that are like you, people that have a similar opinion to yours, and discount agents who beliefs are far from yours, which is basically what most people do. If these people doesn't think what I think, I basically reject and do not even consider updating my beliefs to get close to that. So this is the confirmation bias, and it can be expressed as 1 minus the difference between these two. So when these two guys are very similar, this difference is 0. So the confirmation bias is the maximum, meaning 1. When they are very different, this confirmation bias is going to be 0. So you discard completely the influence of that agent. So what is happening here is that all the agents continuously are updating their beliefs, taking into account these two biases, either the confirmation bias or authority bias. So here's our little example again. We have the peace process with the same agents, the same influence graph. And here's how it evolves in time. Time here, I think, is like 50 units. And as you can see, we really started with different kind of polarized positions. And after a certain time, they actually reached consensus. That means their opinion was similar at some point. And that has to do with this influence graph and the updates that we have. But now we need to, in order not to make the same mistake that La Revista Semana made, so we need to have a proper definition of polarization. So polarization is the tendency of individual beliefs to become more extreme over time in certain conditions. So the idea is that we have high polarization and low polarization on this side. Why? Because as I told you before, polarization increases with intra-cluster similarity and inter-cluster difference. And small groups are not significant. And for that, we used a measure, and a data measure from economy, developed like 3 years ago. And it's called the Esteban-Ray measure. Since I have little time, I'm not gonna describe this measure. I can do it offline. It's basically, the important thing is gonna give me high values if I have a polarized situation and low values if I don't have a polarized situation. So for example, we consider this different kind of scenarios. We have a uniform distribution, meaning that, for example, we have equal number of people in all these intervals. A strong disagreement if you are between 0 and 0.2, like the guys with the peace process. Mild disagreement if you are between 0.2 and 0.4. Indifference, like you don't care, 0.4 and 0.60. Mild agreement, 0.6 and 0.80, and strong agreement. So you have extreme polarization, for example, when you have a group in strong disagreement and a group in strong agreement, like it is the case with the FARC peace with the FARC. And you can also have tripolar. So you have strong disagreement, strong agreement, and indifference. Here I have some pictures of these kind of scenarios. And just to show you that when you have a uniform distribution, the Esteban-Ray value is very high. It's very low, meaning that there is no polarization. And when you have extreme polarization, like in this case here, like everybody's strong disagreement and strong agreement, and then you have the highest value in this particular case, 157. So let's see what the simulations gives us. We consider the following influence graphs, clique graphs, circular graphs, disconnected groups, and unrelenting influencers. This is like the scenario when you have two strong influencers that they influence everyone else or some people, but they don't get actually influenced. This is the case with big corporations, big network companies, or big political leaders, for example. So here is some interesting simulation. This is particularly beautiful when you have the influence graph is circular and your belief configuration initially is tripolar. So you have 3 poles here, one pole, another pole, and this pole. And you can see how this guy, for example, is increasing and then decreasing, increasing and decreasing. This spiral is very interesting. And you can see polarization going down and going up and going down till actually becomes 0. So this is what we are interested in, when the polarization goes into 0. We have this other scenario here with faintly communicating agents, and also the same belief configuration is tripolar. So you have 3 poles. And you can see that this first group, the indifferent, they actually split. And this try to meet the ones that are in strong agreement. And this one tries to join the ones that are actually in strong disagreement. But eventually they actually all reach consensus. You can see polarization here like goes down as they separated. When they get together, polarization increases because then you have like 2 groups here that are relatively different, very different actually. And then as they get closer, this polarization tends to 0. And going back to our peace process with FARC, then you get this picture with polarization evolving, going up a little bit, but eventually turning into 0 when you reach consensus here. So this old simulation is very nice to have this software that you can actually simulate these things, but we need theorems. I mean, formal proofs of statements. We observe this polarization tending to 0, but can you actually prove in what cases you can have this independent of the initial beliefs? So yes, let's consider cliques. Clique influence. Basically, we say that the influence graph is a cyclic if for every 2 agents, the influence is always the same. So it's the same influence in the whole network between every pair of agents. For this one, we have very strong results. You have convergence time. You give me a cyclic, and I can tell you when it's going to reach a particular difference of opinion. Meaning that for every, and as small as you want, for any epsilon that you give me, if I take this logarithm expression, and this is t of epsilon, for any time t after this time, you have that the difference of opinion between I and j is smaller than epsilon. So basically, I know when they're actually gonna agree up to certain distance epsilon. And I actually know the consensus value. So you give me an influence graph, a clique, and I can tell you in the limit when time tends to infinity, what the consensus value of every agent is gonna be. This is also very interesting.
Frank, now, 5 minutes.
Okay, so strongly connected graphs. So, well, you know, for those who do not much about graph theory, we say that an influence graph is called strongly connected if between every 2 agents there is a path from one to the other. So this particular lemma is very interesting because it tells me a lot about strongly connected graphs. If you have a strongly connected graph, for every agent, the belief agent in time of tomorrow is going to be bounded by the two more extremes agents, max T and min T. So for example, and this is just an example, the beliefs of any of us will be bounded on the left by some leader of the left and on the right for some prominent leader of the right. But this is T plus one. Well, it will be obvious. Belief consensus. I do not know what the consensus is going to be. It's impossible to know. But I know that if you wait enough, when T tends to infinity, the beliefs of any two agents is going to be the same if you have strongly connected graphs. And now here comes something very interesting from network theory, from network flow network, sorry, and actually something that you might be familiar with from circuits. We're gonna say that an influence graph is balanced or a circulation if the influence that it receives is the same as the influence that it gives. So the incoming influence is the same as the outcoming influence. And there is a nice influence conservation. If you take any partition of the set of agents, the outgoing influence is the same as the incoming influence for any component. And then for this particular case, if your influence graph is balanced, then you also know what the consensus value is going to be. But that's not the most interesting thing. The most interesting is insightful result, which actually tells me something about polarization. I assume that people know what weakly connected influence is, the graphs is. So it turns out that if you have an influence graph that is balanced and weakly connected, then it's also strongly connected. You might say, well, good luck with that, but it tells me a lot actually. Because if you take this theorem also tells you that in a community where polarization does not disappear, either there is an agent that influences more than she is influenced, or there is an isolated component in that community. So again, because you know that if your graph is strongly connected, then polarization is going to disappear. So if polarization does not disappear, your graph cannot be strongly connected. And if it's not strongly connected, you know, because of this theorem, that either there is an agent that is not balanced, he influences more than he is influenced, for example, or you can find a group of people that are totally in isolation. For example, this one, you can see this is a weakly connected graphs. So you can basically, they are all connected. It's not strongly connected though. And if you simulate this, you'll find that these groups actually, they do not reach consensus, and polarization never goes to zero. So this is something that was very interesting to prove. So just to finish, some conclusions about this work. Social networks have a great impact in today's society, democracy in particular, because they might shape people's opinion via cognitive biases, which may cause polarization. What we did was to present a very basic model for the dynamics of polarization that takes into account two familiar biases from social sciences: confirmation and authority bias, and also taking into account the influence graph. So the model allows us to simulate the dynamics of polarization, and we also be able to prove insightful theoretical results. I didn't say, but these results were proven using standard theory from calculus, which that shows also why calculus is very important. So keep in mind, calculus is very important. And also graph theory. network theory. Future work is obvious, is to make the model more robust, meaning consider all the kinds of biases, consider all the kinds of influence graph, evolution of the influence graphs, and so on. Thank you for your questions.
Wonderful. Thank you very much, Frank. Do we have any question for Frank, please?
Ellos tienen que levantar la manito para poder darles el micrófono, Luis Omar.
Oh, yes, please.
It could be in Spanish, no problem.
Oh, ya. Sí, la pregunta puede ser en español si quieren. Ok, Jan Medina tiene una pregunta.
¿Jan Medina?
Jan?
Pero yo le doy le dejo abrir el ya. Jan, ya puedes abrir.
Como que se le cayó la comunicación a Jan. Okay. Anyway, so I can...
Michelle Guzmán is...
Ahí está Joan Betancourt y Michelle Guzmán. Entonces, le voy a dar a Joan Betancourt y luego a Michelle Guzmán.
Perfect.
Yes. So do you hear me? Oh.
Yes, perfect.
Sí.
Okay. So that was very interesting. Thank you. My question is, there's this very famous internet forum. It's called 4chan. And his main characteristic is that it is completely anonymous. You cannot create an account. And that way you cannot create like, let's say, authority or like create fame or have certain to be know inside the forum. So what we think that this special characteristic will affect, how it will affect your model? But
yeah, thank you. A very interesting question, actually. I mean, yes, that kind of anonymity can actually reduce the problems derived from one of the biases considered, but not of the other one. You see, there is, and this is very important, authority bias has to do with people. Whatever this guy says, I believe, right? It could be contradicting my own conviction. Like, I want to, if you are, I don't know if you're still seeing my screen.
Yes, we do.
So look at this. How do I remove this thing from here? Okay. So this guy here at the end, he is like he strongly opposes the FARC agreement, right? But he's strongly influenced by number 5, strongly influenced. So basically he starts changing completely his opinion because of the strong influence of this guy has over him. In the scenario that the student is asking, that wouldn't be possible because the influence it cannot be expressed. So to answer your question, that could be modeled by having the same, what you are saying basically that everybody has the same influence. In that case, we will be in the situation where we have a clique, like the influence is the same for all agents. And also you still have the other bias, which is confirmation bias. Confirmation bias is independent of the person, is whoever he is, if he agrees with me, I actually trust him. So the forum that you mentioned can avoid authorization bias, but cannot avoid confirmation bias. If in this forum there is a person who is actually agreeing with whatever you say, then you actually start liking this person and reinforcing each other's opinion. Like every time you put 2 people that are from the left, for example, they will actually tend to be even more to the left, the same for the right. So this is what happened with you echo chambers. I hope that answers your question.
Well, I hope so too. So I believe we only have one, we only got time for one question, more question. So what about Michelle, please?
Yeah, I wanted to ask if the influence in the graph can change. Like, for example, if the influence from agent 1 to agent, from agent 5 to agent 0 might change. And also if maybe because of the dynamics of the graph, maybe with the evolution over time, if, that might also change as well. Meaning like, for example, if like at time 0, then the influence of agent 5 over agent 0 is 1. But maybe at time 20, let's say, after debating and hearing everyone else, then the influence change. Is it possible?
Yeah, that's a good question. So basically, you are in this scenario. So, I mean, what you're saying is, of course, true. I mean, you take these people here, the influence that they have, it changes constantly. And we do not have right now this in the model. One of the extensions that we are proposing is actually to have the influence graphs changing with time. And we need to analyze very well under what conditions we change this influence. What causes a person to change his influence? If he says something that is completely outrageous, for example, or what makes you change your influence? That would be very important before changing the model. But yeah, it is very important. But we have played with this. So, I mean, we don't know, we haven't tried to prove any theorems, but of course, if you have a simulator, you can do crazy things, right? So what we did was to take the argument and change the graph at random. And then you will get very interesting pictures. I mean, you will get more often consensus, but you will have also cases where you will never reach consensus. So yeah, we need to consider that future work. Thank you, Michelle.
Wonderful. So guys, I know that this is very interesting. Unfortunately, we don't have time for more questions, but you know that there is a coffee break, so we can ask all the questions that we want during that time. So let us thank Frank and welcome Jaime. Bueno, ahorita nuestra siguiente charla va a ser especificación y verificación de sistemas multimedia interactivos. Y nuestro speaker va a ser el doctor Jaime Arias.